Algebra Tiles. In the set that you actually have 3 different sizes, but I'm only going to talk about 2 of them right now. You have the small square ones, and yours are either tan or they're red, okay? Just so that you know, if they are a tan color, it represents a positive 1. It won't ever be anything other than a 1, okay? And if it's red, it represents a negative, okay? A negative 1. Now, you have the long, skinny rectangles. The long, skinny rectangles represent either a positive variable, being the green, or a negative variable, being the red side. They're we've got dual sides, so we can flip them over for whatever we need, okay? You actually have a larger square, and they are red and blue, which we probably won't be using these at all, but these are the ones that we use for x squared, or the variable squared. Again, the red is negative, and the blue is positive, okay? Typically, the red color is your negative color, okay? When people have done accounting for decades, if their bank account is in the red, that was something that they would refer to. Man, my bank account's in the red, I can't go. Meaning I don't have any money and I'm actually in the hole, or it's a negative amount. I owe the bank money. And so those are a couple of phrases that have been coined over the years. Either you're in the red, your account's in the red, or you're in the hole. And it didn't mean that you were actually in a hole, but figuratively, financially, you were in a hole. Okay? So that's what these stand for, the x squared, positive, and negative. Okay? And I believe the top of page 47 gives you the same breakdown as what I've got here. Okay? Now, your assignment today is going to be to complete this activity, the essential question. What you're going to be doing is finding out how can you use algebra tiles to add and subtract algebraic expressions. So right now we're just simplifying them, adding them and simplifying, okay? So let's look at the first one you have. We're going to write an algebraic expression first. Let's just see if we can take what we've been given there. Now, I give you the tools because sometimes it helps for you to play with my manipulatives, okay? So, now some of you are like, I don't need these, I don't want to use these, not doing it. Okay, if you're successful, I'm good with that. But it doesn't hurt to play games, okay? How many of you like to play games at times? How many of you ever play board games? Ever played checkers?
We did it yesterday.
Ever played chess?
Oh, we did it yesterday.
Okay, that takes you manipulating things with your hands. If you see it, you say it, you do it, it gets into your long-term memory, okay? And that's why I gave you those. So, if I have, everybody's going to get out a green rectangle. If I have a green rectangle and 3 of the tan squares, what did we say that the green rectangle stood for? What did we say the green rectangle stands for, Wesley? A positive what? No, it's not 10. It's a positive what, Savannah? Okay, it's a positive variable. So I have x. What else do I have there on that first one? What else did I have you get out? X plus what? X plus what, Michaela?
3.
X plus 3. It's that simple. There's my algebraic expression. Does it change any at all if I use the red squares and they're not 10?
Yes.
Okay, what's the difference between the first one and the second one? So you need to write the second one so you can identify what's different about it. Landon, tell me, what do I write for these 2 green rectangles?
2x.
Very good. Yes, it's exactly 2x. 2x plus what? What else do I have there? Zane?
Negative 2.
Negative 2. 2x plus negative 2. If you got that, give me thumbs up. If you already had it, I want thumbs up. Okay, good. Let's go to, I gotta get it to where I can slide it. I want you, do you have, I think yours is C on your paper?
Yes.
Does C look like this one?
Yes.
They're doing something to us here. They're doing something to us here that we haven't talked about. Does anybody know what I'm referring to? Paige.
Don't you have to cancel out the negative and the positive, which would leave you with positive?
Okay, why do I cancel these two out? Why? You're right, but why? What do we call this group right here? And I haven't used the terminology today, but we have in the past. What do we call that? What do we call that, Aaron? 0 pairs. Good. So if I go back to my first page where I had that, the positive and the negatives, anytime I have a positive and a negative, I have what is called a 0 pair. They cancel each other out. Okay, those are 0 pairs. Okay? With that being said, I want you to write your algebraic expression. Everybody has to write it on your paper first. Do what? So write what you think. I want you to think before we talk about it. Let's see if you're catching on. Okay, I see something here, but you're missing something that should be attached to it. Yes, check the rest of the table. Yes, check the rest of the table. Yes, check the rest of the group. Check the rest of the tables. Yes. Table check. Table check. So what should I have up here? Zoe. 2x plus 3. Absolutely correct. 2x plus 3. I have 2 x's. And as I walked around, I did see a couple of you that said 2. You've got to throw the variable with it because that's what that stands for, is that variable. Okay, and it could be x, y, z, q, v, double a, which they normally don't do, but it could be. Okay? All right, so with that being said, I'm going to skip around a little bit because some of this you're going to do without Mrs. Rakestraw. Okay. I want you to turn to activity 2. It's on the bottom of that page? Good. Activity 2. You've got one that looks something like this. Okay? And the only difference is on yours, because you don't have it in color on your paper, is they've thrown a positive sign in on each one of these. Okay? So that you can tell that's what they are. It's another way to model it without using the colors. Okay? Now, what it wants you to do is add these together. Okay? So I want you to build these. This is where the manipulatives come in extremely handy. Build this for me. So you should have a green rectangle with 2 squares, positive squares, and then another green rectangle with 4 positive squares. You're building what is right here on A. I want everybody to build it on their desk. I want to see it. It's real easy to see if you're doing what I'm asking. Just do it. Then is it also easy for you to see what you have? That you could simplify this expression once you get it built. And if you simplify this expression, what do you have? Somebody tell me what you have here. Caitlin.
2x plus 6.
Caitlin says 2x plus 6. Do you all agree with her?
No.
Okay, I have some questions here. Okay, I have 2 x's. Do we agree with that?
Mm-hmm.
And then I have 1, 2, 3, 4, 5, 6. 2x plus 6. Can I solve for it? No, it's an expression. I can't solve it. I can only simplify it. Okay? Now, what if I went in here and, if it'll let me do this, and I got too many things open now. Okay, what if I went in here though, and I said, you've got it built, right? You have it built. I want you to take these 2 positives over here, your first 2 positives, and flip them over. I want them negative. Flip these 2 to a negative. To red, exactly. And I can't do it there because it's not going to just let me go in and change it. But if this was a red instead, if I said red and red, now can you use that, and do you still have the same answer, or can you manipulate it around and tell me what you would have if 2 of those were red? If the first part of that algebraic expression is x plus negative 2 plus x plus 4, what should I have, sir?
2x plus 2.
2x plus 2. Do you agree with him? And see what that does is it allows me to put together that 0 pair. Okay? So I've got a 0 pair here. I got a 0 pair here. They're gone. I've got 2 left behind.
2x plus
Okay? 2x plus 2. Good. All right, now look at the third one here. Activity 3. Flip it over. Because I'm going to be quiet in a few minutes and let you just do the work. You and your partner, your shoulder partner there, are going to compare, okay? All right, so I want you to build the first part of this algebraic expression. Build the one on the left. So you should have a green rectangle and 3 positives. Am I right?
Yes.
Okay, now then, it says take away a green rectangle and 1 positive. What's left behind?
2.
When we simplify it, what is left behind? 2. Is it positive or is it negative?
2.
It's positive because if I'm going to say, and I can use a picture to show this just as well, I'm going to say, well, this is gone. And it says take this one away. It's gone. So now I've done what that said, and what I have left is 2. I could have written this as, oops, sorry. I could have written this as x plus 3 minus x plus 1. We said final answer is 2, right? Remember when we say subtract, now, but this says x plus 1, how's come I ended up with only 2 when I had x plus 3?
Plus minus.
This is, what did you just say?
Add opposite.
This is my add opposite opposite.
Add opposite opposite. Whoa.
Because everything that was in the parentheses now had to flip the sign. I had to take it away because it said take it away. And when I took it away, the only thing that was left behind was 2.
Yeah. Wow. Whoa.
Okay? What I want you to do for the rest of this time, and really it's pretty simple, is I want you to complete the rest of this adding and subtracting linear expressions essential question, even to the point where on number 6 it says, write the difference of 2 algebraic expressions modeled by the algebra tiles, then use the algebra tiles to simplify. So you're completing it all the way, kiddos.
Yeah.
Finish the whole thing. What was that? Okay, okay. And yes, it's you and your shoulder partner. Okay? You and your shoulder partner. Do I have anybody that does not have a shoulder partner? I have one here. Okay, Caden, I'm going to let you join the group there. Maybe, and it may be that you go ahead and work it and then just check each other, okay? All right? Michaela.
Do we have to finish